Hey everybody, this is Larry. I'm doing a practice Codeforce contest on the last Division 2. Codeforce round 649. The virtual contest starts in a minute. There's a link to the left. Feel free to go check it out. That's so you could follow along. I cut off half the screen because mostly it's just you just need to see what problem I'm working on, I think. And it's not, like there's a link. So yeah, let me know what you think. I'm still playing around with how to show this in a good way. So yeah, definitely leave some feedback, leave some comments, join the Discord, ping me, let me know. But yeah, I'm just gonna practice this div 2 and see how it goes. And it starts in about 37 seconds. So I guess we'll hang out until then. You can watch this live on Twitch. If you're not, then, But yeah, I'm a little bit jet lagged coming back from Hong Kong, back to New York. But I also just want to, get warmed up a little bit. In this contest, I'm going to try to focus, but I'll also try to articulate a little bit. So I'm not going to be at 100% speed per se. But, it's a journey, and that's kind of have fun together, I suppose. And here we go. 1, 3, 6, 4, 8. Okay. Oh, it's only a 5-problem contest, huh? That means it's going to be interesting. I usually do better with more problems because in theory I could solve more. Okay, he loves number theory. For some reason hates number x. Three test cases. N and x. There's a lot of reading for these ones. But second. The longest subarray cruise sum isn't divisible by x. N is the number of elements, is that right? Okay. Which 2, 3, okay. Longest subarray sum that isn't divisible by x. Huh. Okay, let's pause the input first. Oops. Was it t is okay, and x. I'm still using C style scanfs. That's just from a long time ago. It's not, I don't know if there's any good reason for it. Maybe I should learn to do better, but okay. And then we just have to read it in. X is this, and okay. And then now we just okay. Okay. So how do we get the longest sequence where it doesn't work? Okay, so given that n is less than 10 to the 5th, we probably want something linear or something like that, or n log n. N squared isn't going to cut it, is what I mean. It's kind of funny because I know how to solve the opposite of this problem very easily, but I'm trying to think how to solve this one, meaning if it's the longest divisible by x, and can we figure out something from after that? Well, if there's no subarray, I mean, my mind is just thinking about some variation of greedy algorithms, because that's probably how it's going to be. Can we solve the direct one? Oh, actually, the thing to notice is that all these are positive numbers, but it doesn't really matter because we can actually we should pre-process it by multiply, and then now after we multiply by x, we just have to figure out the longest subarray where the sum is not 0. Can we do that in a greedy way? So the naive algorithm that I would think about is, and I'm using Emacs by the way. So from each index, so the n-square algorithm will be from each index, you go all the way out, and then for second index, is there some kind of invariant that we can use some kind of sliding window? Man, I'm struggling with the easy today, but that's why you warm up and that's why you practice. But for each element you could do a brute force on x, but that's not good enough. Basically, you want the x. I guess we could just do the dynamic programming and then try to do some greedy that way, but that seems really sketch. Maybe. But basically what you want is for each index contain the element that would give you 0, and then what, give you the earliest entry that's the case. So then that earliest entry plus 1 is good. Man, I'm just struggling a little bit with this one. Maybe I just woke up in jet lag, that's my excuse. But okay, I think we could just go no, this should be 10 to the 4th, so okay. Oh, there's only 5 cases, okay. I really struggle with these A's lately. Like I do better on the harder problems, but these ones are like some weird ad hoc thing, and I definitely struggle with that one. Okay, let's reset the thing. Okay, and then now, well, so what does the earliest thing that gives you 0 tell you? Oh, and this should be this, and then so now we want to do something with previous of 1. Oh, and this is I think there's something dumber than this. I'm just being dumb. Okay, so if they're all 0s, then it's not good. If it's 1, this guy. Is it just the first instance of I mean, I think I'm just thinking about this in terms of prefix sum. This is a pretty slow way. And let's say we have a prefix sum. Can we go backwards? Wow, it's a good thing I didn't do this live because wow, I am struggling. Okay, so it doesn't exist if it's all sums to 0, so we could fix that. -1. So we know that's true. So now that we know that there has to be at least length 1, then well, what does the prefix sum mean? Okay, now I think I got it. I think I'm just being dumb. Okay. So basically, when you're processing from left to right, okay. If the element is 0, the running sum is 0, you find the earliest non-zero, and if it's 0, then you find the earliest non-zero, or the other way around, non-zero, then you find the earliest that number. I guess that's what we were trying to do. If it's earliest 0, no, it doesn't have to be 0. So we say you find the min of all the numbers that are not including that number. That's gonna be n squared, right? The prefix sum is 1. Yeah, okay. Well, what's a better way to learn than embarrassing yourself with a simple, easy problem, right? But no, I think it's okay. I think these ad hoc things are always a little bit tricky because it's always like this one-off thing and you miss an observation and it could take a while. And it's okay. It took 12 minutes for an A and it's not even done yet, but yeah. If it is a non-zero, then yes, you can look for non-zeros, but if the prefix sum is non-zero, you could go from the beginning of the array anyway. Okay, so this is 0, we do stuff, otherwise it's non-zero, so then max is equal to max of I plus 1. And this is what I talk about in terms of invariants, and invariants are super important to kind of go through as you think about it. Thanks, Boston, Mass. Okay, so with a 0, we want the first non-zero number, which is something that we could keep track of. Okay. Oops. Use the same variable. First is equal to I, could be I plus 1. And sometimes the thing is that once, even if you feel it properly, because when you don't know it, you may be unfamiliar with it, and then that unfamiliarity means that means that you keep on rediscovering the property, and what I mean by that is I think I discovered the property twice, where I was like, okay, the 0 and non-zero case. This is actually a good problem. I like it a lot. And now you're just seeing me clicking through trying to submit this problem because I forget what directory this stuff is in. What is going on? The web Larry is bad at this. I have to set it up so that I could just command line this. But it's a 64. Okay. Probably should test this a little bit better, but today I'm a little bit lazy. I want big money. Oh no, it's slow, meaning it's probably not right. Okay. Did I miss a case? Could be off by 1. Yep. Okay. I should have tested at least the off by 1 case. Okay. So these answers are okay. Just one of those days. It's a very good thing I did not compete in this one then. But okay, 2. So I think this idea should be right though. Oh, of course it's gonna be wrong. So the first is let's just say infinity or something. Let's just say n, because I never said it. Oh, and this is I'm just being careless. This is I think the algorithm is still right, but sometimes you rush it a little bit once you like, oh, I see this idea, and you end up doing stuff. Or at least that's what I do. I get a little bit too excited that I didn't really think it through, and this is my problem with A's in general. Like I do better because I am a little bit arrogant for problem A's. It's still wrong though, because I didn't really test it again. Okay, well. Is this off by 1? This is the first index. Sorry, let's just I was just being lazy. I need to actually test these things. This is 0, so this is 2 because okay. Also, what is wrong with me? This is not like I said, sometimes you rush things even though you because this is not supposed to be happening. This is supposed to be running sum, not the actual number. Okay, this time I'll try to take a little bit longer, so that will make sense. Let's say what are these numbers again? Oh no. That's impossible. What? Then X. Is my inputs wrong? No, it's X. Oh no, I had my input in the wrong order. Whoops. Wait, is that true? I don't know anymore. Oh no, I just deleted an input by accident, that's why. Okay. A lot of silliness. Okay. Is that one isn't correct, is it? That's why I want X. Oh, again, I did this in the wrong order. Whoops. I'm really sloppy today. And that's why we're practicing, I suppose. Okay, that is my expected behavior. What's about 2? What's my computer's a little slow? 3, is that right? Cannot be the last one. Okay, let's submit this. Okay, cool. So they did get it right, but after 2 submits, and we'll go over it at the end. Sorry if I'm skipping ahead, but I do want to make this a virtual contest instead. But yeah, this is Emacs, and if you're watching on YouTube, so I'm just answering stream questions. So it may sound like I'm talking to myself, and usually I am. But yeah, okay. Let's take a look at the second problem. Given a permutation P of length n, find a subsequence. Is as big as possible. Of at least 2, such that all subsequences of P given a man, these things are so hard to read when you just woke up. Given a permutation P of length n. Okay, you want a subsequence of at least 2, which is as big as possible. Okay. Choose the one whose length k. What's k? What? Socially. So okay. Let's look at an example. You have n is equal to 3, 3, 2, 1. So then on 4 subsequents of a length 2. Subsequence. Okay. So basically we want a subsequence such that we remove certain elements and the deltas of the absolute values of the adjacent elements are the biggest. Okay. I think this ends up being so the thing to observe is that here if you have 3, 2, 1, you could remove the 2 because if it's between 2 numbers you can just remove them. And now how to formulate that? And you could just keep on doing that. I think you could do it with a stack or something, going left to right. Yeah, just the last 2 numbers. Basically, you want to go all the way up and then all the way down and so forth. The only case that doesn't maximize it, I think that's right. So, and ironically, I get the algorithm for B way quicker than A. Even though I still have to code it, so I wouldn't celebrate quite yet. But yeah, okay. So what do I need to do? Let's do the input first. 10, 1, 2, 4, 5. Oh no, it's telling me to update, and then now I lost my typing. Maybe I need a real keyboard. Yeah, this setup I do have a chat because I have a second. I have my phone to tell me what people are saying, but still should focus a little bit. But that's okay. We're just here to learn. Okay. So basically, do we always want the first number? I think that's my question. Do we always want the first number? I guess so, because you can never get that back. Okay, so then we just basically, okay. Okay, I think I have an idea on how to implement this. And if I could type, that would be great. But this is always that's. If t is less than 1, then we just put it on. I guess we actually just do the first 2 elements instead of this weird statement. Okay. If a sub I, basically what we want is if this number is okay, if this is true, we is equal to a sub I. So it's this statement or the other version of it. Else a sub t is equal to a sub I, and then increment t. Okay. Oh, I have to. What are we doing? This sequence. Okay. Yeah, outputting stuff would be nice. Rusty. Okay. Well, this is a little off because this is T, not N. Also, we have to print out T. Let's start submitting it. Oh, I should have tested the N is, oh, okay, it works. Okay. I was going to say, but I need to test the N is equal to 2 case. So yeah, I got this one in 9 minutes, way faster than my A. It happens. Okay, and a lot of that was reading. Given an array A of length N, find another array B such that of length N such that max is minimum excluding. Yeah, okay. So all the elements that don't contain this What is 0 mean? How to find b such that oh, I see. So this prefix is 0, so this is 1. This prefix is 0, 1, so this is 2. This prefix is 0, 1, 2, then this is 3. Okay, so it's not all the numbers, it's just the prefix. And this is hard to read sometimes. I mean, for me, the problem is actually very well stated. It's just that you have to get used to practice. You have to practice reading these things so that it makes sense to you automatically. Okay, it's increasing, which makes sense. Otherwise, you just can't get it. So let's see if I could figure out from principles. This is tricky. But if this is 0, what does that mean? If the first one is 0, that means that the first number is not 0. Okay, that's reasonable. It's still true for the second one, but you still have to come up with it. And I think the 10 to the 5th, okay. I mean, this is a constructive algorithm. I should be able to get this, but just about finding the patterns. Well, the first number that doesn't have 0 is going to be 0. Okay, and then for that number, everything before that will be dancing around that number. But then now we have to force that in a more continuous way. For example, if there's a 3 later on, then you can use 3 here, right? Okay, so let's think about what this means. If the number 2 here means that these things cannot be 2. 0 means that so now you have all these conditions, which is actually just a problem statement. But how do we construct that? Well, we know that the first one is 0. And what is the second one? Let's say we have another 2 here. What does that mean? Well, that's just a random big number. If it's 3, then also a big number, but that means that the prefix cannot be that. Numbers are between 10 and 5th, and we could just choose random big numbers. Okay. I think we could keep track of forward. Going forward, what do you need? Okay, let's play around with that idea. And 10 to the 5th. Yeah, it is a little bit global-y. I am used to picking up a case. Basically now, for each number, we want to use the smallest number that doesn't appear in the prefix. So in a way, it's like another max. Like, does this have to be a 3? I guess not, right? These could also be 1s. Unless we have to force a number later. Like if there's a 5, then we need to do that. And we could do the max with a binary search with binary index tree to calculate the number that doesn't show up. Is that a real thing? So 1. Because you always want the biggest number so that later on we can use it. That doesn't show up. Alright. In this case, we want to pop to 0, pop to 0. So for the first 0, we take the smallest number that doesn't appear in the rest of the set. Well, in here, is that true? In here we need a 1, because if we don't have a 1, then we can't get to 3. So there's a 0, that's fine. This is a tricky part. Do we put things on the stack? Yeah, I guess we need a stack. Well, what's an impossible situation? An impossible situation is... Well, the first one has to be... So that means impossible situation is if n is greater than n. Is everything else possible? I guess so. Actually, I don't know whether that's true, but we might have to play around that one. So here we suffix is 1. 1 is good. 2, we try to put 2 is used, so that's no good. What does this 2 mean? 2 means that there has to be a 1 on the left of this and a 0. And you can do n square. Can we do binary search? What does this 2 mean? This 2 means I mean, it seems like you can just do greedy, but you have to be able to implement the greedy. Okay, I think I have an idea, but I'm not quite sure. Ten to the 6. I know it's just numbers that I use, so 10 to the 5th is fine. Okay. I don't remember counts a keyword. It might be. Yep. I don't think it is in C, but it is in C++ if you have standard library put in. Sorry if I'm talking too low, because I'm still deep in thoughts. But, okay. This is 0, we still need to respect the 0. Okay. Now I need to answer. Yeah, okay. This does one. This... I have to handle this too. Alright, let's see what this returns. Having trouble visualizing. Stack is ambiguous. You're not wrong. I don't print anything. We really need to put this in a helper or something. Seems fair. Okay. I think for a new number we have to check the top of the stack. And what is the top of the stack? Because we need to at least take one number from the top of the stack or in the stack, but that could still be like we have a decreasing sequence or something. Right? Okay, we'll play around with that. I don't think this is quite correct. I need one more observation, but okay, I don't think the stack is the right property. I think what I need is a hash table of sorts. Okay, basically, if this is correct, we put it into consideration. Okay, I think now I get it. I think now if this is equal to 0, then we can let's just point out something. Freeing up. So current. So we free up 0, so we should add that to be the considered. Because as soon as we free up a number, we should be able to use it. So we should put it on something. Okay. Well, the S is not a stack anymore. And then now, so this order. So we want to get the minimum number. Okay, fine. So then let's put in a set. Because we want to insert a sub I, and then now we want to do something like if that's is greater than 0, and as how to get the min of something. I'm just gonna Google it. Hang on. Set min. It's been a while. Begin. Set that begin. Is that already sorted? Okay, fine. Damn, this website is not working, and also my light just went out. It's okay. You don't need to see my face that much. Okay, so okay. If is less than current. Yeah, then we start begin. Is that the pointer or the? I think I need to do yeah, this. And then now as that we move delete. I don't remember how to do these things. How do you delete stuff? Is it delete? That's not right, right? Set delete. Erase. Okay. Whew, I hope you. I know that there's a lot of thinking in my thought process inside my head in this one. Oh wait, no, I got a wrong answer on one of them. We only do this if. But mostly at the end, I think I need one more condition where we don't. Okay, if we use the current, we just don't put it in because we already used. Okay, we could probably figure out some invariant, but I'm just going to have a used thing. Use dot insert current if you define wait, how does that make sense? Why is this 1? Because we pop off the 1 so we get to use it. Wait, what? Don't know if this makes sense. Hang on. Hold up. Cleaning up the 1. Oh. So the current does not okay. Let me think about invariance. Because basically I have 2 pointers and I'm trying to keep them in sync, or free up the one, so we should use the one. The one is able to be used. I guess we could just actually do is that good enough? Apparently not. Because we want to move to counter. Which one does it? I guess it's not clear where it is. Just curious which one happens first. But so okay, so at here we have 1 and 2, but because we already used 1 here, okay, here's more like if is that good enough? Now I'm not as confident as I did before, but still I hope that the thought process was helpful. This is a tricky problem, obviously. Well, I say that, but not out of the woods yet, so let's submit and then see. Oh, cool. New intern class, hopefully that's fun. And how's it going? Submit the right thing. Yeah, okay. I mean, 4 test cases before it's wrong, that's always good. But I guess I should have tested more cases. Yeah, I'm just playing around with what's going on. I don't know how. Don't know what my logic is wrong, so I'm just trying to find a counterexample. Okay, that seems right. It might be that yeah, this is wrong because I need a 2 for this to be right. Why don't I do a 2 though? Because this is, where's the current? Popping the 0, that's good, but this should also be popping the 2, right? Okay, I mean, it's good that it was very easy to find it's both good and bad that it's very easy to find a case where I was wrong, because then I wish that you know, that this came up. But this doesn't seem right. This should have a freeing up 2 from here? Oh, because the 2 is popped. So then I never did this check. Okay, so I have to do this check. Okay, okay. So yeah, okay, that makes sense. But then now we can just do else. This thing. Okay. Silly mistake, maybe. Oops. Okay. And in theory, I would test a little bit more, but now I'm going to prove by AC instead because I'm lazy and this is just practice. But that's a pretty bad habit actually, so maybe I should practice doing that. But maybe I'll take a look while I'm doing this. But it's a good step, I guess. Oh, it's HC. Okay, so I did just had a silly mistake. But album mostly right. That was pretty fun though. Half an hour. Oh, hope you enjoyed that half an hour of me just going, huh, huh. But okay. Catch up. 58 minutes. That's enough time to do a problem. I do. Jeez. Gotta charge my phone. Hang on. Okay, half an hour should be enough for me to solve. An hour should be enough for me to solve this problem. Though it's not soon, but let's give it a go. Give a connected undirected graph of n vertices and integer k. You have to either find an independent set. What the? Okay, well, this may be a go home and take a nap early kind of situation, but independent set that has exactly k over 2 vertices, or a simple cycle of length at most k. Oh, I'm back in New York, so that's how my beautiful background in my fridge. Yeah, that's also why I'm jet lagged as heck. But an independent set is a set of vertex such that no two of them are connected by another. Okay. I have a proof that for any input you can always solve at least one of these problems, but it's left exercise. Okay, that's cute. Interesting. That means I'm gonna learn something today. That's always exciting. N, M, and K, vertex, edge, and then the K parameter. Simple cycle of length at most K. I mean, it feels coloring E. And it feels like one of those things where, well, either this is true because of the two coloring, or you find a simple cycle because something like that. I mean, I'm definitely very hand wavy here. I'm not a, you know, but for example, you could find an independent set by 1, 4, 5. Is 2 coloring enough? Well, I mean, not 2 coloring, but try to find. But K is really big, so we have to do something smarter than. I don't know. So it's going to be some sort of depth first search in either case. But the question is, you know, just knowing it that it's depth first search doesn't really solve the problem enough. Simple cycle of length at most k. So maybe, let me think about some induction thing. So if there's one node, oh sorry, if k is 1, then it's trivially true. If k is 2, that's also trivially true. If k is 3, well, it's trivially true to detect. Now, for k is 0 to 2, it's also true for all cases, right? Because you just either find one vertex. So 3, you either find 2 independent ones, or you have a cycle. Yeah, I do love immediate feedback loops for learning, but yeah. So you have like a triangle, say, and either it's a triangle or if it's anything else, then yeah, okay. I mean, and the question is, yeah, you can't just do breadth first search on an entire graph, right? Because then that's no, well, no, you can't do another search on an entire graph. M is greater than n, so it's a connected graph. It's connected and doesn't contain any self loops or multiple edges. I think this English is a little bad, but maybe. Can't do a naive thing. Can we just do a... Yeah, I think we should just do a cycle finding. With the first search with at most k, does that come into play? I guess it could get higher than k. Where's the length of a cycle again? It is not... Thanks, Twitch encouragement. I'm encouraged. you know, all the techniques the thing. So what I'm thinking about is just that the techniques that I know are all like exhaustive searchy, which is a little bit well, not what you want to do in terms of complexity. Um, hmm, Time limit is a little lower than before. But yeah, you can't really do it for each node. You have to be able to do it for each thing. Okay, let's say we do that for search. What does that give us? That gives us a search tree of the graph. Or even breadth of search, it doesn't really matter. It's just a tree, a connectivity tree. And finding a cycle is easy, but I just don't have experience with finding a cycle of at most length k. So I'm going to do something right now where, because we have 48 minutes left, I'm going to check the standings just to see if it's easier for me to do yi, possibly. And the answer is no. And also a lot of people have done D in a quick way, so okay. I feel like I'm missing something really obvious, but can you find a cycle that way? I guess so. But I think we want a shortest symbol cycle, so and we can find the shortest. A symbol cycle is a cycle that doesn't contain any vertex twice. Because can you just go back and forth? Or am I like really confused? In the first example, 214. And we don't really have time for an all pairs shortest path type thing. So we have to do it in one depth first search, or breadth first search. Get the shortest path from A to B, and then so you have something like this, then you can really do a shortest path. Or like you can really cycle one. Independent set. think I have to do these both in the same time to get this, but well, this is what they call in the business a hard problem. At least hard for me. I'm really glad I didn't do this live, or like the contest. Just a lot of silliness today, but I mean, I don't know what I'm looking for. I knew how to. All right, let me just take a look at Yi. I'm not able to wait, but no one has submitted this yet, right? So that's actually oops, what am I doing? Doesn't make sense to go for Yi if wow, I'm also really behind. How did I just get to first page? Now people have done Yi, just order really red people. So okay. Depth of search is definitely a weak part of my game. So are these directed, undirected? So I still don't get what a simple cycle means. Can it just be a simple cycle of 2? Or am I missing something out? Like, why can't it just go 1, 2, and then 1? Yeah, maybe that doesn't really matter. I guess I'm just being an idiot. So we could definitely find cycles, but the cycles of length k is the part that, or at most k is the part that I'm not really familiar with. Can let's say we have a tree from node 1. What does that mean? Okay, I mean I think we have to create a tree in that case. And then now, so let's say we have this tree. And then in this tree, if in this tree, we just have to make sure that all the things in the same level don't have edges to each other. Is that right? So one, no, or in alternate levels don't have edges to each other. That's right. So all the stuff that's too distant away cannot have edges next to each other. And you could do stuff with union fine maybe, but because if they do, then you could just use that to construct a cycle of length k. Okay, I think that makes sense. Yeah, as you can see, I haven't even looked at this thing yet, but let's play around with it. And is this a one input thing? Yep. Do I need the shortest path, or is that for search okay? Maybe it's okay. Oh, the independent set part has to be exact, not at most. I think that's probably the part. This is gonna be hard, but that's at least. Now I'm trying to think about the independent set part of exactly k/2. But yeah, again, I think this is what we said earlier, where we're just two coloring stuff. Okay, yeah. Yeah, let's just use depth of search to greedy color two things, and then either things are an independent set or they yeah, or they are not. Yeah, okay. And we'll probably have to use union find or something like that to see. Tender. I guess this is actually a singular. Yeah, okay. Should use auto more often if I try to learn something new. Maybe I should just use okay, it doesn't crash. That's always good. Oh, I forgot. Well, I guess if we color it, we don't actually need the parent part because your parent is always colored. Oh, whoops. I don't color everything, don't I? Oh, this is -1 because I updated it. Okay. So now let's put all the, let's try all the odd nodes and all the even nodes. And either they create a cycle or they don't. So now we want to think about okay. I think I'm just trying to think about node selection and whether greedy is good enough, and I guess so. So basically, we just greedily try to see if we have an independent set of k over 2 vertices, and if we do, then we're done. And if not, then we just use those if they're not independent, and it could be any k because they're either independent for k over 2, or we can just construct a cycle from them from using the intermediate nodes. But that part might be a little bit trickier from how I'm constructing it. So So I might have to keep track of a few more things, but I think that's the general idea. Let's try to solve the independent set part first, and then I would solve the cycle part later. Okay. Okay, union fine, right? X. Not sure if this gets challenged. I need to spend some time doing it, but that's fine. Because there's path compression, it should be probably okay, but let's think. Okay. I don't know that I don't know if I need to do it both for odd numbers and even numbers, but I guess we'll see. Or even colors. And let's just take a candidate set k, k over 2. Yeah, let's just put no vector so we don't really have time for this. Now we have to test whether this is independent by union fine. put this closer to here. Do we want? Okay, that's actually, I think we could use a set. I guess we actually don't need the union find now that maybe I think about it, but because we can just, because I was worried about the end. Okay, well, we'll remove it later. So for each node, if node is in what does this mean? This means so I think I want to do this a little bit differently. I want to so if we find an edge then that means there's a back edge, or not a back edge, but just a cross edge. So we want to do something about this XY. Okay. Yeah, I guess we don't need the union find, actually. Implemented all this stuff, but you know, it's good practice. But instead of breadth first search, I may want to do depth first search. I want to use breadth first search and then do it that way, because then I think we could construct the cycle easier. Okay, how much time do I have? 21 minutes. That's going to be a little bit tight. Should it matter? No, but because right now, just because it's just harder to construct a cycle that way. Okay, fine. I think we can. Maybe we'll incorporate this together. So for the breadth first search, we just put the first couple of things that are in there. Okay. And this is a distance, not color anymore, but we'll still do it that way. Yeah, okay. Yes, that's not necessary. This distance doesn't matter, but you still need to know the parity. We don't even need this color anymore because we're going to just try it anyway. Yeah. Is it front? Okay. "17 minutes." Ooh. Oh. Okay. And now okay, so now we have 1-3, that's good. We test 1-3. Either the independent sets or we found a cycle, and then now we want to connect the paths from one. So now we just have to connect it from 1 to x and then y. 1xy, okay. But then now if we have the cycle, that doesn't otherwise, let's just print out everything in set. Alright, 13 minutes to go. I don't know if I could finish this in time, but hopefully I should be able to upself this a little bit afterwards. I was a little slow today. That's okay. I have to look at the test cases manually because when these cases they all have an independent set, so that's actually kind of unfortunate. But let me try to create one where I guess a triangle is okay. Oops. Try and create a case where there's a cycle and no independent set. So okay, so let's just say an octagon then. Yep. So now I'm trying to think how to construct it. So now you have X and a Y, and they both create a cycle. So we going back to the parent. So okay. Okay, I think I have an idea. In this case, the answer should just be okay. I mean, I don't know if I could get this in time, but it'll be close, and even if I get a wrong answer, it's probably fine. I think I have most of the algorithm right, even though it took a long time, but yeah. So now, let's just say, I could just do it here, it's fine. Okay. Okay. Then common is the root. So now we want what do we want? So we want to X and then Y, and then Y to its parent to common, and then x2 common reversed. Okay, so let's just put this way. Okay. Let's put in a answer thing. Too tired to try to figure this out. X. Let's just put it on the stack. How's it gonna Y? Well, the process is running, right? Oh, this is silly. That's what I get for using the same names in places. This is infinitely looping for some reason, so let's take a look. And now I have 6 minutes. Is it here? It is. Oh, did I set the parents not correct? Did I not set this at all? I thought I did. Okay. I actually don't even need this. I just need... I thought about this, but I guess I just messed up. Okay, still an infinite loop, but at least it's stopped being here. And also this is because this is common instead of now. Okay, I have to print out the array. Okay, 4 minutes. Cutting it close. See if I could get it in 4 minutes. This is not right though. Oh, because we double counted the x and the y, so 3, 4, that's fine. And this should be easy fix. By moving this. And we also don't... Yeah, we solve the parent of x. So I think I forget the size of this array. I have to return that. But 3, 4, 5. I think I'm missing a 1. So I have to. Oh, I have to push the common piece. So after the what? And also print. Three minutes. Cutting it close. Exciting times. Okay, 3, 5, 1. Okay, that looks okay. Yeah, I mean, I think normally I would test maybe a little bit more, but at 3 minutes, that's just YOLO. Okay, I mean, at least I passed a couple of tests. I might still be the wrong answer. Seems like it's wrong, but I think I'm mostly close. Just a little bit tired, and that's unfortunate though. I mean, maybe I'm missing some edge case, but this feels right. Can I fix this in 2 minutes? Seems hard, but okay. Let's say 4. What's the answer for 4? Wait, it failed on. So it failed on one of these cases actually, right? If it failed on wrong answer on test 3, did I just not look at it correctly? Let's see. 1, 2, 3. So this one. Simple output. Well, 1 it seems too crappy of an answer. Oh, I see. So my n is wrong. Why is that? Ooh, okay. I mean, I'm gonna debug this. I guess I won't finish in time, which is kind of sad, but I'm close. I think I missed an edge case about something, which is sad, but that's okay. Glad this was not a real contest, but still. Did I? Oh, I see. I mean, I knew this was the case, but I see that it has immediate edges, but not so this is clearly wrong. Whoops! I just rushed it a little bit. I think my algorithm is still relatively right. I just need to handle an edge case where okay. But then now I think now the problem is okay. I think I thought about this, and then now I have to do it for another number, because this is something that I said at the beginning where I was like, okay, well, I don't know if I don't know if I need to test both parts of the two coloring, and it turns out I do. So close though. This is really bad code, by the way. I think this is true because of maybe pigeonhole. Let's see. Nope, it just doesn't print anything for this case. Which one, the graph, or is it here? The third example, 1. Oh, everything is 1 away and everything is 2 away. Well, nothing is 2 away, so it doesn't create 1 there either. How do I handle this case? Two, 1 and 2, 3. Well, the 3 doesn't make sense because we should return anyway, right? How did that happen? If we look for K, right? Did I do the K wrong? Oh, it should be, okay. If it's equal, we also want to go out. Okay. And then now, my output is 2, 4, 1, which is, okay. Still good. Is that all I needed? Well, so I had a couple of minor mistakes as well, but alright, let's try again. I'm missing a... That was bugging me a little bit. Okay, I mean... Seems like it's gonna be okay. It's still running. There are a lot of test cases for this one. What does that mean? Oh, I didn't use this? No, I guess oh yeah, that's right. I knew that. I mean, I knew that afterwards. Okay, cool. So I came in a little bit under the contest time, but that's okay. I think for me it's trying to learn, and I actually spent another entire hour on that problem. Probably shouldn't have. I think I was just trying too hard to, as a postmortem, I think I was just trying to do too hard. I didn't even look at this. I'll have to look at this later. But I was trying too hard to see if there was a smart algorithm. When it was just a very ad hoc, you have to do everything kind of problem. I'm gonna go over at least from A to D because those are the ones I finished. I didn't even look at E. So yeah, and definitely I'm also responding a little bit to chat. So if you're watching on YouTube, and if you're watching this for, I don't know why, but yeah, you could get to that. Problem A, XXXX. Okay, so the kind of, so actually I'm gonna change this a little bit so that's easier for explanations. Okay, and then now let me just, I need one of those drawing pen things. Yeah, let me know what you think. This is still something that I'm experimenting with. Yeah. So I do need a drawing pad, maybe. But yeah, but the idea behind this problem is just that, for me anyway, and we could go over the tutorial later actually. But yeah, but basically the thing is that okay, you take every number and you multiply by x, and then now there are only a couple of cases, right? For the running sum. Actually, I don't know why I put it out. Hang on. Let me bring this back so I could show you the code while I'm going over it. But basically, you have for problem A, you have this. Let's say you have a prefix sum, right? And the prefix sum, by definition, means the sum of all the elements from element 0 to the current index. And well, we might order the prefix sum by x because we just care about whether it's whether it is 0 or not, right? And let's say if the current prefix sum for the current number is 0, what does that mean? Well, with 0, that means that from the beginning of the array to the current index in the array, it is 0. Or like it's divisible by x, right? And what does that mean? That means that the longest subarray that ends in this current index is the first element that the prefix sum is not 0. Because if the prefix sum is not 0, then it's basically I'm just waving around a lot, but basically, let's say you have I think with some basic visualization, this is pretty straightforward. I need to get one of those drawing pads, but let's say you have a prefix from like 1 to 5 or something like that, and your prefix sum is some weird things like this, and there's some zeros in it, right? Something like that. It doesn't really matter. But basically, when you add this 0.0, I don't know, the font is a little bit hard to read. Let me double check. Yeah. Let's say your prefix sum here is 0, then the longest subarray that ends at this current element is just the first place where it's not 0, which is 1, right? So that's pretty much what I do for the first part of checking if it's 0, then that's the case. If as we're going from left to right, if this number is 1, well, if this number is 1, then the earliest prefix in which it is not 1, which it could be anything really, as long as it's not 1, well, you already know what that is. It is literally at the beginning of the array. So taking the entire subarray as the sequence is a possible subarray where it's the longest, in fact, subarray that ends in the current index. And that's basically what I did, even though I implemented it terribly. So I got 2 WAs, 2 wrong answers for this one because I was just silly. But basically, yeah, if the current prefix sum is 0, we take the current index and then we just subtract it from the first index where it is 0, where it is not 0, and then here we keep track of if we haven't marked this yet, then we set it to I, and then otherwise we just keep track of this from the first element to here. So that's kind of how I did it. I guess visualization could be a little bit better, but yeah. So that's Q1 or problem A. For problem B, which one's problem B? Most socially distant subsequence. So this one I found a lot easier than the first one. Let's look at my submission time. Let's take a look at my fake standings. So I solved this like literally 3, 4, or 5 minutes right afterwards. So yeah. But how does this work? Okay, does this work for answer? Okay, yeah, I solved it right afterwards, so I don't know. So given that, I don't know how the time points would have been, but let's say I had 3,100 points, where would I have been? Yeah, okay, let's just say not that great, but still pretty okay. Wow, people did it way faster than I did, I guess. I think actually, okay, so if I had finished it slightly faster at 30, wow, people did it so fast that my 4 submission. So basically at 3,100, this would have been essentially the last. I don't know what. No, even at the very last minute, you get 1,000 points. So if I had done it within time, I would have gone maybe 3,700, which would have been top 600, which for Div 2, I think actually would have mean I gain rating, whatever that is, because anyway, just curious. So I think I did pretty okay. I just needed to be faster on problem A, really. From B and C, I think I did okay in terms of timing. In B, I took 9 minutes, and in C, I took half an hour plus a wrong answer. Okay, but B, most socially distant subsequence. The key observation in B is noticing that that for 2 numbers, 3 adjacent numbers, let's say you have 1, 2, 5, because basically the 2 parts of the problem, one is the this absolute value delta thing, which means that you cannot get rid of certain numbers. But basically, let's say you have this, just looking at array subsequence of 1, 2, and 5, right? So now this is an increasing sequence, and what that means is that, well, the absolute value of 1 minus 2 plus 1 minus 5, or sorry, 2 minus 5 is just equal to the absolute value of 1 minus 5, right? Because you can move the middle element around and it doesn't matter. So this is the invariant that we try to keep up. And then now we just have to keep doing that one at a time, looking at the first 2 elements. If the number is if any number is in between 2 adjacent numbers, recursively, if you want to call it that, then you just remove it. And that's basically my algorithm, and that keeps the sequence. And another thing to notice, an observation about this problem, is that the sequence so the thing is that the input will always have this property. The input is always as big as possible because you can't insert any numbers, and so you can only make it smaller. So the thing that you want to do is hold this in a way such that the value, the max sum of adjacent deltas remains the same, and it remains the same when you remove numbers that are in between two numbers in adjacent things. And that's basically my algorithm here. I go, okay, if this number is between, if and I construct this in a weird way, but that's I could have probably used a vector and this would have been more direct. But basically, also I don't use, I think I when I was doing this, I did this in a weird way, which actually ended up to be okay, but actually I did not do this intentionally. Now that I look at my code, I'm like, wow, Larry's just being careless, because this should be R, this should be R, and this should be R, and then, but yeah, so I kind of did an in-place algorithm by accident, because we move things in a way that only goes from left to right. So that was very accidental, and actually that's kind of cool, but not intentional. That was just me rushing it a little bit. But basically just every element, for every t minus 1, the last element, if that element is between the previous element and the next element, then we just remove it. And we remove it by putting the new element a sub I into the last element. And then we just print it out. Yeah, so that's the two observations you have to make. The one is that the input is always going to be the one that maximized this already, and two is that to find the smallest one, you have to just remove elements that are adjacent, that are in between stuff. Okay, let's do C. Yap and prefix max. Yeah, so this one I had a silly mistake about. So I took half an hour on this one because I was just trying to think, trying to be a little bit careful about it. Perhaps too careful, because my standings were terrible if I didn't finish this one. If I finished it, it would have been okay, but I was very close to finishing, and top people are really fast about this. But the idea is going left to right, we keep count. Yes, Qual, I will take questions after this. But the key part of problem C is noting that, okay, so I keep track of two things. One is all the future numbers. So we go one past, we do a one pass to keep track of all future numbers right here. We keep track of all the future numbers that we cannot use. And then once we go process them, once we process those numbers, here we allow them to be used again in this line, which is that we subtract numbers from numbers that we can use, and then once we're able to use it, and then at any opportunity that we can, we will use the smallest number that is available in a greedy kind of way. And we put this by keeping in a set, and otherwise we just use the biggest number that we can, and that's what current is for. And the observation is that it is just greedy. At every point, you want to use the smallest number possible. That we want to use the smallest number possible, taking account that in the future we cannot, like for example, if we try to use 2 here, that's bad because in the future we need a 2, so that's why. And then so this is kind of like yeah, and in fact, yeah, so after that realization, and maybe that realization is not that hard, that observation, it becomes an implementation problem, and the implementation problem is kind of tricky and is just figuring out that as you process them from left to right, process these numbers from left to right, certain numbers are available again. For example, here we have 3 zeros. After the third 0, we're like, okay, friends, we can use 0 again. So we put it in the, what I do is I put in a set so that the next time we can use the smallest number, which is what we did. And yeah, and that's kind of problem C. I took a long time on this, but it's okay. And the current keep tracks of just the biggest number that we can use, and this is all of n log n because we only we only look at each number once and so forth, or twice maybe. We've only output each number once, so yeah. Okay, let's go with D, the one that I have trouble with. Yeah, so I mean, I think this one I took way longer than I really should have. I think I was playing around with trying to find a better algorithm maybe, but the idea is there's some sort of pigeonhole E principle E, which is what they were saying, but the idea for me is just having two colors, and that's the I talked about this while I was doing it, but then I forgot about it by the time I submit because I ran out of time. But the idea is that, well, an independent set, so you have two colors, right? So and it doesn't have to be a strict two color, but you basically color it by the distance from a root. And it could be any node, it doesn't really matter. You could just pick a random one. But so now basically, okay, I think this is the part where I need to pull up Microsoft Paint. It's not even Microsoft. I'm on a Mac. I don't know. I guess it's just drilled into me to say Microsoft Paint. But let me pull that up. Window. No. Okay, I need to move that up, I suppose. And then move it all around. Okay, so basically the idea is that, okay, you have some nodes, and you create a depth first search tree, or breadth. I actually end up using breadth first search because it was easier to construct. And it doesn't have to be a binary tree, of course. But this is just given any graphs, right? So this is a tree because we use breadth first search, then we're going to get a tree. Right. So now let's just say, and then you dot the rest, right? It goes more, but whatever. And then the idea is, okay, well, let's say we have a candidate set, then let's say we have, so we just greedily take, what's it, k over 2 numbers, right? So you take the root, and then you take numbers such that it's up to k. So then now we just have to check whether there are edges from each of these nodes to another. If the answer is no, then you're done, because, and the way that we construct it is because we took distances that are odd or even numbers away, basically multiples of 2s away, in the two coloring kind of way. That on each of these levels, that on each of these two levels, or multiple, there could be more, that we just do a dot here on the bottom, but on these levels, then by definition they don't have edges between the two different areas or levels, right? And then the question is whether there are edges between, let me change the color a little bit. Are there edges, okay, yellow is terrible. Are there edges between, these two, inside these cycles or inside these levels, right? And that's basically what my code does, is check for that. And if the answer is no, then you're done because you're given an independent set and there are no edges between them. And that's what the problem asks for. But what if there is an edge, right? Then if there is an edge, then what I did is that, well, then that means there's a cycle, because you can, and the way that I did it is, let me choose the English to color again. No, stop using yellow, Larry. Okay. What I did is for each node. So now let's say there's an edge between these two nodes, right? The red edge. So then now we know that there's going to be a cycle, and you can kind of already see it in the visualization that there's a cycle. But basically, what I did was I take this node, I go all the way up to the parent. Basically find the LCA, the lowest common ancestor, find the parent in which they're equal to, or find a parent in which they have a common, find an ancestor in which they have a common piece, and then we're given this node. So then now we just create that cycle, and that's pretty much my algorithm. And I really should have done that in less than an hour now that I think of it. But these graph forms are always a little bit hard for me. And then the question is, how can you prove that this is less than k? Well, at the worst case, let's undo this for a second. Let's just say for whatever reason we chose these two nodes. Well, here then for every two nodes that you pick, and there's an edge between them, well, the common ancestor will always be at least root. So this will always be the common ancestor, and you know that this is some distance away, which is it's going to be less than k over 2 by definition, because there's a lot of pigeon. I don't know how to do the proof to kind of convince you, to be honest. But you could play around with it. But the idea is that this will, if this goes to the root, is you could draw different cases in which this is true, which is you have just k over 2 lengths to the left, k to length to the right, and then you could pigeonhole it to having a more common root, right? But basically the idea is that this goes up at most k over 2 times or something like that, and this also goes up to k over 2. It's a little bit tricky to prove, but you could play around with this idea, and so this combining with this edge that we connect, this creates a cycle of at most length k. And of course this is the worst case. If we took okay, maybe it doesn't undo anymore. There's too many undos. Let's say we took this node because we took these two nodes. Then, obviously the cycle would be much smaller. And that's how I did this problem, given that I took way too long. Cool. Yeah, that's all I have for this part of it. Hope you enjoyed this screencast. And you can also follow me on Twitch, and we'll hang out. And I'm going to do the live hanging out part about now. But yeah, thanks for watching. And yeah, cool. But yeah, this is still an experimental, so let me know what you think.